Good morning, students. In the previous lecture, we have started basics of chapter 2. We have already discussed what is a random variable, what is discrete random variable, and what is continuous random variable. Today, students, we are going to discuss the theories of binomial, probability, distribution. Students, 2.1 has been removed from the syllabus, so at present I am not discussing that. In the previous lecture, students, we have already discussed what is a random variable, what is a discrete random variable, and what is continuous random variable. Let us revise this in nutshell. A random variable which can assume countable, a random variable which can assume countable or finite values or countable infinite number of values in the set R is called a discrete random variable. As discussed, countable infinite number of values means very large number of values. The meaning of countable infinite number of values means, students, you can say a very large value in terms of number. So in nutshell, a random variable which can assume finite or countable infinite number of values in the set R, where R is set of real numbers, is called a discrete random variable. The best examples for this are, say, number of children per family, number of broken eggs in a box of dozen, and birth year of a randomly selected student. Number of printing errors per page of a textbook, number of road accidents per day on the highway. All these are the best examples of discrete random variable. Then, students, what is continuous random variable? A random variable which can assume any value in the set R, or a random variable which can assume any value in an interval which is subset of R is called a continuous random variable. I repeat, a random variable which can assume any value in the set R, or which can assume any value in a specified interval subset of R is called a continuous random variable. Height, weight, temperature, weight of a newborn baby in the range of 0 to 5 kg, life of an electric bulb in the range of 100 to 500 hours. All these are, students, examples of continuous random variable. Now, students, today we are going to discuss and develop the theory of binomial probability distribution, students. In mathematics, I am teaching the topic of binomial theorem, so sometimes I may say binomial theorem. Today, students, we are going to develop the theories of binomial probability distribution. In fact, this is, students, based on binomial theorem only. Now, students, all of you pay attention. Our first definition is of dichotomous experiment. Dichotomous experiment, even we can say dichotomous experiment. Say, students, we may come across some experiments which has only two possible outcomes. In practice, students, we may come across some experiments which has only two possible outcomes. Say the best example, you appear for an examination and there are only two possible outcomes of this experiment. Either you pass the examination or you fail the examination. you cannot pass and fail at a time. Now, out of these two outcomes, we call one outcome as success and another outcome as failure. So what we are discussing, students, try to understand. In practice, we come across random experiments which has only two outcomes, of which one we call as success and other we call as failure. The best example I gave, you appear for an examination, you pass the examination is success, and you fail the examination is failure. Then, type of a screw manufactured by a machine in a factory. Say from a box of screw, I select one and I check whether the screw manufactured is defective or non-defective. Non-defective is success and defective is failure. You give a drug to a patient, drug means medicine, and that has impact or not. If that drug affects the disease and he is cured, that is success, and he is uncured or not cured, that is failure. So, we are discussing an experiment, which has only two possible outcomes, of which one we name as success, students, and the other we name as failure. Such experiments are called dichotomous experiment. So our first definition for today's lecture goes for dichotomous experiment. A random experiment which has only two possible outcomes, out of which one we call as success and another we call as failure, is called a dichotomous experiment. Dichotomy. This is the way students to study the theory of binomial probability distribution. So the first concept in binomial probability distribution is, students, a dichotomous experiment, a random experiment which has only two possible outcomes, out of which one we call as success and another, students, we call as failure, is called a dichotomous experiment. Best examples are given. You appear for an examination and you have only two possible outcomes. Passing is success and failing is failure. Type of a screw manufactured by a machine in a factory. Non-defective is success, defective is failure. You give a medicine or a drug to a patient. Disease cured, success. Not cured or uncured is failure, like that. Then, students, pay attention. So these are, you can say, the possible examples of a dichotomous experiment. Again, I can say, tossing the coin is also a dichotomous experiment. Let us suppose getting a head is success and getting a tail is failure. You can even take tail as success and getting head as failure. It is up to you. But out of two outcomes, one outcome we have to name as success, another outcome we name as failure. Now, students, the probability of success event. Success is denoted by S and failure is denoted by F. Probability of success event is small p and probability of failure event is denoted by small q, where P and Q are definitely between 0 and 1, where P and Q are definitely between 0 and 1 and such that P plus Q is equal to 1. Of course, this is very important. Say getting probability of getting ahead is also 1 by 2 and two are mutually exclusive and exhaustive events. Success and failure are mutually exclusive. Nothing is common between them. So their intersection is null set. And if I unite, I get the original sample space. So in a dichotomous experiment, success event is denoted by capital S, failure event is denoted by capital F, probability of success event is denoted by small p, probability of failure event is denoted by small q. The values of probability p and q are always between 0 and 1, and addition of the probabilities of its p and q is 1. You know the probability, students, can never be greater than 1. Now students, our next concept in this theory is Bernoulli trials. Students, next, one of the most fantastic concept, Bernoulli's equation. That equation is one of the fantastic discovery in physics, because of which you can say an aircraft lives. So, what are Bernoulli trials, students? Pay attention. A dichotomous experiment can be repeated n times under identical condition. Let us consider our dichotomous experiment of tossing a balanced coin. Say, standing on this stage below the same roof in front of the same whiteboard, I can repeat the dichotomous experiment of tossing a coin, say 50 times, 100 times, 200 times, 1000 times. Now, in each trial, the probability of success remains same or not? Yes, students. I toss a coin. The probability to get a head, which I have called as success, even you can call tail as success, then head will be failure. Out of 2, 1 outcome is success. So, a dichotomous experiment can be repeated n times under identical condition. Let us carry forward the dichotomous experiment of tossing a coin. So, we are tossing a coin for n is equal to 100 times. So, I am repeating the dichotomous experiment of tossing a coin 100 times. Now, in each of the trial, irrespective of the previous trials, the probability of success in the probability of getting ahead remains same or not? Yes, students. Even if I toss the coin for 10,000 times, or even if I toss it for 100,000 times, that is 1 lakh times. Students, the probability of success in each trial remains same. Such trials are called Bernoulli trials, as this was first suggested by Mr. Bernoulli. So, whenever you repeat a dichotomous experiment n times under identical condition, in each trial, the probability of success, that is small p, remains constant or same, then students, such trials are named as Bernoulli trials. We are carrying forwarding our theory further with the dichotomous experiment of tossing a coin, because tossing a coin has, students, 2 possible outcomes, out of which one is success and the other outcome is failure. Getting a head is success and getting a tail is failure. So, students, now the formal definition of Bernoulli trial: suppose a dichotomous random experiment is repeated n times under identical conditions. If in each trial the probability of success event or probability of getting success remains same or constant, then students, such trials are called Bernoulli trials. The best example, students, you can say is the dichotomous experiment of tossing a coin, say n is equal to 100 times. Students, a very hot favorite question of the examiner, very odd theoretical question of this topic: define Bernoulli trials and state the properties of Bernoulli trials. You can say once in a 5-year asked question.
define Bernoulli trials and state the properties of Bernoulli trials.
So the definition as per the textbook goes like this. Suppose the determinist random experiment has two possible outcomes, success and failure. If this experiment is repeated n times under the identical condition, the probability of success in each trial remains same or constant, then students, those repetitions of random determinist experiment are called Bernoulli trials. So remember, a determinist experiment has only two outcomes, and out of two outcomes, we define one of the outcomes as success and another outcome as failure according to our need and convenience. So this is, students, the definition of Bernoulli trials. This is, students, the definition of Bernoulli trials. The next concept is properties of Bernoulli trials. Properties of Bernoulli trials. I told you the possible or question from this particular topic is, you can say, define Bernoulli trials and state the properties of Bernoulli trials. A very interesting and important question. The properties are like this. First property, the probability of success or probability of getting a success in each trial remains constant or same. Of course, say getting ahead is success on tossing a coin. Then you toss a coin n number of times, irrespective of the previous trials. The probability of getting ahead in every trial remains same. That is 1 by 2. So the first property of Bernoulli trials is the probability of getting success at each Bernoulli trials remains constant. Then Bernoulli trials are mutually independent. Say I have tossed a coin for 5 times. Now again I am tossing for the 6th time. Then probability of getting a head or tail in the 6th trial is independent of the first 5 trials. So Bernoulli trials are mutually independent. This means getting a success or failure at any trial does not depend upon the previous number of trials. I told you, when you toss a coin repeatedly in any of the trial, the probability of getting success or failure is independent of the previous trial. Success and failure are mutually exclusive and exhaustive events such that P plus Q is equal to 1. I told you, getting a head and tail, intersection between head and tail is null set. And when you unite head and tail, you get the original sample space of tossing the balanced coin. So, success and failure events are mutually exclusive and exhaustive. And their probabilities P and Q are such that the values are always between 0 to 1 and P plus Q is equal to 1. P plus Q is equal to 1, students. That much we have to perfectly understand and remember. So summarizing the entire topic of Bernoulli trials and this property, let us discuss once again. Suppose a determinist random experiment has two outcomes, which are success and failure. In the n trials or in the n repetitions of this determinist random experiment, the probability of success in each trial, that is P, remains same or constant. Such trials are called Bernoulli trials. The best example which we have carried forward today is tossing of a balanced coin, saying 100 times. So,
repetition, identical repetition are Bernoulli trials. Then what are the properties of Bernoulli trials? The first and the foremost property, students. The probability of getting a success at each Bernoulli trial remains same. You toss a coin for 100 times. In each of the 100 trials, the probability of getting a hit, which we have called as success, is always constant. That is P is equal to 1 by 2. Then Bernoulli trials are mutually independent. That is, in each of the succeeding trial, the probability of getting a success or failure is irrespectively independent of the previous any number of trials. Say you have tossed a coin for 48 times and now you are tossing for 49th time. In the 49th trial, the probability of getting a success or a failure is independent of the previous 48 trials, which have been, students, already executed. Then you can say the success and failure events are mutually exclusive. Intersection between head and tail is null set, and if I unite them, I get the sample space of tossing a balanced coin, which is HT. So, in Bernoulli trials, students, the success and failure event are mutually exclusive and exhaustive, and their individual probabilities are small p and q such that p and q lies between 0 and 1, and addition of the probabilities p and q is equal to 1. So, these are the three basic properties of Bernoulli trials. So, what I am telling students, one of the possible modules of this topic is define Bernoulli trials and state its property, asked in examination for 3 marks. Next definition is binomial random variable. Binomial random variable. We have already discussed random variable, students, in the previous lecture, Thursday, which is taken online. So my next definition is binomial random variable. Now students, we are carrying forward with the same example. Say we have performed a dictamous experiment of tossing a coin, n is equal to 100 times. So number of Bernoulli trials are n is equal to 100. Now students, of this 100 times, we have got success for x times, say x is equal to 38. So of this 100 trials, 38 times I have got x, which is success. So 100 minus 38, 62 times I will have got it. So suppose a dictamous random experiment is conducted n times. I am continuing with the example. Say we have tossed a balanced coin for 100 times, and those 100 times of this 100 trials are Bernoulli trials. Of this 100 times, I have got head for 38 times. So number of success are how many? 38. You can get 62 also. You can get 29 also. You can get 88 also. In short, this x can assume value 0, 1, up to 100. All 100 times you will get a tail is one of the possibilities. All 100 times, students, you may get a tail is one of the possibility. So what I was discussing, suppose a dictamous random experiment is repeated n times under identical conditions, and that is nothing but Bernoulli trials. A variable x denotes number of success. Say we have got 38 times head, meaning 100 times 38 times 62 times we have got tail. So the variable x denoting number of success in n Bernoulli trials is called binomial random variable, and this is discrete because it can assume only finite or countable number of values. What example I have given students, you try to understand. Say a balanced coin is tossed 100 times. Of this 100 times, we have got 38 times head, which is success. That 38 is denoted by a variable x, and x is nothing but number of success in 100 Bernoulli trials. In general, suppose a dictobus random experiment is repeated n times under identical condition. The variable x denoting number of success in n Bernoulli trials is called binomial random variable, and x is definitely a discrete random variable because students, x can assume only finite or countable number of values. X is a discrete random variable because students, x can assume always finite or countable values. So in short, what is the binomial random variable? The random variable x denoting number of success in n Bernoulli trials is called binomial random variable. Last but not least, what is binomial probability distribution? Last but not the least, what is binomial probability distribution? Then I can say the probability distribution of binomial random variable is called binomial probability distribution. So, summing up, we were interested in finding or defining binomial probability distribution. So, what is the definition of binomial probability distribution? Then I can say the probability distribution of binomial random variable is called binomial probability distribution. Probability distribution means what? For different values of x, the total probability 1 is distributed. You distribute total probability 1 between possible values of random variable, here binomial random variable, that is simply called probability distribution. So, what do you mean by probability distribution? Remember, for different values of this binomial random variable x, probabilities are distributed. The total probability 1 is distributed between the different possible values of x. So, in short, what is binomial probability distribution? I can say the probability distribution of binomial random variable x is called binomial probability distribution. And the formula for binomial probability distribution is this, students. We have studied binomial theorem. So NCX p raised to x q raised to n minus x, where x can assume any value from 0 to n. This formula we have to memorize. This is written on the generator formula. If you remember in binomial theorem, we have written a general term formula. Refer your 11th standard textbook. It was like this: NCR a raised to n minus r b raised to 1. So based on this only, the binomial probability distribution formula is derived. So refer your 11th standard textbook, chapter 6, exercise 6.3. So this we have to remember. So in short, what is binomial probability distribution? And I can say the probability distribution of a binomial random variable x is called binomial probability distribution. The formula for binomial probability distribution is this: NCX p raised to x q raised to n minus x. N is number of Bernoulli trials, x is number of success in n Bernoulli trials, p is probability of success, q is probability of failure, and and in NCXC stands for combination, that all of you know. So in this formula of binomial probability distribution, capital X is equal to small x, that small x denotes number of success in n Bernoulli trials. P is the probability of success, Q is the probability of failure, and small n denotes number of Bernoulli trials. So this formula NCX P raised to X Q raised to n minus x, that is derived on the basis of general term formula for binomial distribution. Binomial theorem. Students, why the recorded lecture is uploaded? Because you can refer this theories 3 times, 5 times till, students, you are very thorough with the basic theories. That is why I have uploaded this lecture. I didn't take this lecture online. The motive behind uploading the lecture, you can refer this lecture 2 times, 3 times till you are very, very thorough with the basics of binomial probability distribution. So hereby we conclude this lecture, and I assure you, still if you have any doubt, we will solve it in line. But I have explained in such a way that, students, now you may not be confused, or you will not be left with any doubts. Still your doubts are most welcome. Now in the next lecture we will take properties of binomial probability distribution. In the next lecture, that will be also uploaded, and we will take the properties of binomial probability distribution and a few short sums based on the properties of binomial probability distribution. Thank you, students. We conclude the lecture. See you soon for the next lecture.